Let's begin with one assumption. Assumption is, if I see an effect within a manufacturing organization and I can find the cause, on removal of this cause, the negative effect then should go down significantly. This is the assumption of cause and effect. Whenever we see some effects within a system and we are able to find out the cause, removal of such a cause should, in all likelihood, if we have got the cause right, the effect should be significantly reduced. In normal parlance, we call this cause and effect. I used significantly reduced because many times the effect, the final effect, is not only the resultant of one cause. More than one cause could lead to the final effect. Hence, if we remove one cause, the cause we think is causing that effect, the negative effect should be significantly removed. This is one assumption we are making. Applying this to manufacturing organizations or the complexity of manufacturing organization leads us to ask a fundamental question. What do we need to do to improve production? Let me reverse the question. What are the issues involved in production that make it a complex situation to manage? If I ask this question to somebody in charge of production, he will begin to say the customers, they keep changing their priorities. Sometimes this is important, sometimes that is important. And because of that, we also need to replan everything, and that leads to a lot of complications, and we lose a lot of efficiencies because of setup changes and the batch sizes get impacted. Okay, that's one. Second, is it okay if the customer doesn't change his mind? The supplier does. He is unreliable, and trying to make my suppliers reliable, I have two sources, then I need to manage the two sources. Supplier is an issue. Let us say even if the supplier supplies on time. Then comes the issue of manpower. I have absenteeism and I have to live with 2 to 5% absenteeism. There is a measurement to everything, negative impact within the organization. We do supplier ratings, we measure absenteeisms, and even if there is no absenteeism, we say, okay, the skill levels of my workers are not very good. So we have great training programs. After all that, he said, oh, my processes are not reliable. That means such a sensitive process that we don't always get a consistent output. That means we allow for variation in output. So then we have a process that comes into play. If the process is stable, we can also have the quality in play. That means quality may be my 98% plus, but still the 2% variation can get compounded with absenteeism, with late delivery, and the final impact could be very big. Let us say all this is in order. Or then people say, fine, this is not all. The list still carries on. The list is that we try to impose so much of policies to improve, but sometimes they still don't lead to improvement. So constantly there is a shuffle everywhere. Now I just listed so many sources from which disturbance to smooth manufacturing can come. And if this is the list that one is often faced with, what would happen that I give you a small environment where none of these so-called negative effects exist, and on top of that you are allowed to select all the policies that you want, and then can you actually manage this operation smoothly? What we very often hear are the main source of trouble in production environment. Are they really the main source? The only way to find out is, how about creating an ideal situation where such negative impacts can be systematically removed, or an ideal situation where I can isolate the full negative impact of all the listed problems. That means, if I give you an environment where the customer never changes his mind, there is no absenteeism, the suppliers always deliver on time, the quality is always consistent, your processes are always stable, workers are excellently trained, and you have the ability to choose all the policies that you want. Can you assure that you will be able to manage the organization to such a level that the demand is fully satisfied? Let's take one such environment. And since this is not possible in real life, a small pictorial representation or a small simulation could help us understand. What we will see in this simulation is nothing but an application of all our scientific ability. That means we have organized the resources well. That means there's a resource layout. We know what our resources are. We know the routings or the process layout. That means how a raw material systematically, step by step, gets converted into finished goods. And what is the sequence in which the resources are used to convert this raw material into finished goods, which is called the routing. Not only that, we also know that we have some policies, efficiency-oriented policies, like to make sure that my machine is used more productively, I have also the ability to put a batch size. That means only after this batch size has been processed on the machine can the material move on. And all this how? Because one of the greatest ability I have is to have an access to data which is the most accurate. That means I'm seeing it all with my naked eye on one screen. That means I have an ability to get an access to the data instantly and not fudge data, because it is this data, technically a report, which forces me to replan or helps me to replan. And very often organizations implement very sophisticated information systems to have an access to this report or data. So here is an ideal situation where you have the access to the most accurate data, you have all the forms of data available. That means you have a process layout, you have a machine layout, you also know the data required. That means you also know the capability, the rate of production, as well as the setup change times. Let me take you to such an ideal environment and then apply all the policies that we currently apply and see if the final effect is as we thought it is going to be.
To help one understand how the policies and the procedures of a company impacts its ability to manage its production, here is an example or a simulator which actually tries to create an ideal situation. An ideal situation is a situation in which all the listed inherent variation source are removed. In other words, this is a situation where the customers will never change their mind, absenteeisms are zero, the skill sets of your workers is so good that they always produce at this rated output consistently. the quality rejections are not there, the vendors will always supply on time, and above all this, you also have a great visibility. That means the reporting systems and the planning systems are so good that whatever is happening on the shop floor can be easily viewed by you. One of the common things that we hear in manufacturing organization is our information system is not very good, and we put in a lot of money to install softwares so that whatever is happening on the shop floor can be very accurately reflected at the manager's table. So let's go ahead and let me explain to you what you're seeing in front of you. On the leftmost at the top is a clock. We will try and simulate 1 week of operation in a few minutes, and that is the reason why we have a simulator. So it says that it is week 1, day 1, and then time. The moment we unfreeze, that means we start running, the clock starts working. Now it is such an ideal situation that you can just press stop and the clock stops. Naturally, in real time this is not allowed, or this is not possible, but it is a simulation, and in fact by stopping the clock I'm giving you a chance to make sure that you take all your corrective actions. You think, take time out to think, then again take a corrective action, and only when you are convinced that you have a correct decision to be made, you go ahead and implement the decision. Below that is another round box, round space, and this is telling you that you have 10,000 cash with you and your fixed expenses per week is 11,000. Now this is also something which most people in manufacturing organizations are oblivious about. You need cash to run a company. If you have to pay your vendors, you need cash. So here is an accurate display of cash with you. If you buy some raw materials, you will see that the cash gets deducted. For example, let's look here. Here I need raw material. The moment I buy 20 raw material, the cash goes down. 20 into the cost of the raw material is deducted from your cash. The good part is you can send the raw material back if you don't want. It's a simulation. Below that is a button which, if you unfreeze like this, it turns into green. That means it says it's running, and when this is running you will see the clock ticking. So this is week 1, day 1, and 10 minutes of the first day have passed. So here is a nice, you can say, IT system which is telling you what's happening. Next to that column is a column where we call the machines or the work center. This tells you what all resources are present with you. The squares are nothing but your machines, and they are identified by unique colors. So you have 1 blue, 2 greens, 2 cyan, 2 purple, and 1 brown. This constitutes all your machines, and next to them under the setup column is their setup change time. So if you change a green machine, that means you allocate the green machine to a new product or a new process, it will start producing only after 120 minutes have elapsed. Similarly for light blue, it will take 60 minutes, and only after 60 minutes will it start producing. The brown one has got no setup time. Now to the right you see a matrix. Matrix means it's a grid. There's column A, B, C, D, E, F, G, H, and rows 1, 2, 3, 4, 5, 6, 7, 8, 9. So the machine gets allocated to A1. Okay, if I put a machine here, for example, I take this and I drag it and put it here. This is called allocating the machine. The machine says it is under setup and it is allocated at A1. Now what you see in this grid is nothing but a process layout. It says for you to manufacture this product, which we call product A because it is in column A, you would need one of raw material A, one of raw material C. Both these raw materials will get processed on the green resource, then they land up on the brown resource, and after that it goes to green resource again. It is very common in industries for the material to come back to the same machine. Okay, so here is an example where we say that the green machine processes, it goes somewhere else and again comes back to green machine. After that the blue, purple and again light blue, and it is sent out. Where you see red is either raw material or finished good. Squares is nothing but inventory. So what you're seeing here is there is inventory of 25 lying in front of the brown machine. That means this inventory can be used by this or by the blue to process. When you look here, there's inventory of 15 available, inventory of 10 available. Okay, this is nothing but WIP. Now let's look at the product D. D, the demand for the week is 50. For product F, the demand is 40. So you have three products and you have their processes laid out in front of you. If you look at product F, first operation is done by the green machine, next operation is done by the light blue machine, then by the purple machine, then blue machine, then purple machine, then light blue, and goes out. We know that we have two light blue machines, so we will have to take a decision which one to allocate where. We'll also have to take a decision which one to make first, because by simply taking the machine from here and putting it here does not mean anything. You need to have a plan that in what sequence will you make, which product will you make first, and depending then on your resources will you see the feasibility of the product being made. Now nowhere in a company is such a visibility available. I know my processes very clearly, and I also know which product will go in which machine and in what sequence. That means the routings are clear. What you see written within these round boxes is the rate of manufacturing. That means one unit is processed in 8 minutes on brown here, then it goes here. One unit is processed in 15 minutes and then it goes here, another 15 minutes per unit, 20 minutes per unit, 18 minutes per unit, and the product is dispatched. It can happen that you have processed more than the demand. If you have processed more than the demand, it will lie in the finished good inventory. So you know where the inventory is lying. You know how much of raw material is lying, because it's a very simple thing. If I want to procure raw material here, I can just tap here and say please send me 50 raw material. 50 comes. So it is just to say that your vendors are reliable, the quality is okay. As and when you want something, it will be delivered to you. This is a simulator.